Hello, my name is Mingming Jiang. Today I'll talk about my project. The name of my project is Simulations of Face Recognition. First, I'll talk about the target of my project. I studied the algorithms of face recognition, and then I write the MATLAB code to simulate face recognition. I write two parts of the programs. First, I write a simple program to recognize the faces, and then I write a program to simulate the performance of PCA and LDA algorithms in face recognition. At last, I evaluate results get from the simulations and obtain the conclusions. Then I'll talk about motivation. Face recognition has been a very important part of modern technology. It has been used in several areas, such as network security, multimedia information processing area, and the communication area. Also, plenty of algorithms are also raised, such as PCA, LDA, and LPP. It is significant to simulate these algorithms and their performance. Then I'll talk about the background. PCA is a method to analyze sets of data. PCA uses few samples to describe a large set of data, which makes it implement the function of reducing dimensions of data. PCA is also widely used in face recognition. It reduces the dimensions of images and applies lower dimension data to describe the information of image. LDA is also an important algorithm in face recognition. The main purpose of LDA algorithm is to set up a vector matrix based on samples to obtain information and reduce the dimension of space of samples. It is usually applied with PCA algorithm to reach better performance. Now I talk about the simulations. This is the most important part of my project. This simulation is divided into two parts. The first is the detection part. The main purpose of this part is to use a simple algorithm to detect the position and the size of the face in image. The second part simulates the performance of face recognition by applying PCA algorithm and LDA algorithm based on some parameters, such as numbers of training samples, processing time, and correction rate. After the simulation, I get some results. Look at these four images. The first image is an original colorful image, and the second one is a grayscale of this image. In the third image, it do some processing, it minimizes the background to understand the face of the man. The last one is the result image. The face is marked by a red rectangle. This rectangle contains most part of the face of the man. Therefore, for this image, the algorithm is accuracy. I also simulate different images of this algorithm. The first one is blurred. I mean the whole face. The second one is clear, but the background is blurred. The image C is clear, and the image D is short by one side. After simulation, I got this result. And the accuracy of image A is lower than accuracy of image D, and this is lower than accuracy of this image, and the accuracy of this image is lower than the accuracy of image B. So I can conclude that blurred image when blurred image is used, the accuracy of this program is lower, and when the clear image is used, the accuracy is higher. But when the background is blurred and the accuracy is highest. This is the result of the part 2 of my program. There's 4 parameters: the number of training samples in each class, the optimal dimension, and the correction rate of face recognition and the processing time. From this table, I can get 2 conclusions. First, when the number of training samples increases, the correction rate increases also. And we can find that when the number is 8, the correction rate is 100%. So this is why I limit the number to 8. Then, when the number of training sample increases, the processing time also increases. This also proves that I need to limit the number to 8. Now I talk about the conclusions. When the number of training samples increases, the correction rate also increases. This means more training samples lead to higher correction rate. When the number of training samples increases, the processing time also increases. This means the efficiency of the program get lower. These conclusions show that if we want to have high correction rate, we need to sacrifice the efficiency. Therefore, we need to choose a proper number of training samples to balance these 2 parameters to obtain the best performance. In this project, the number of training samples can be 8. Thank you. Now I talk about the program of my project. The code is read in MATLAB code. This is the first part of the of my project, and this part is used to input the images and change it into grayscale. This part minimizes the background of the image to understand the faces in the image. This part is to detect this part is to detect the image and use a rectangle to mark the face. This is the second part of my project. This part determines the parameters. Determine some parameters like the number of samples and so on. This determines the the number of training samples, and this import the images from database. Then I use PCA to lower the dimensions, and use LDA to calculate SB, SW, and SB. SW is the distance of samples in each class, and SB is the distance between 2 classes. These are 2 very important parameters. Then I imported test samples to compare with the images get from above and get the correction rate. I also calculate the processing time to estimate the efficiency. This code used to implement the function of PCA, and this code is used to read in the samples from database, and this code is used to this code calculates the optimal vectors, and is used to higher the correction rate. This code calculate the SW and SB by using LDA algorithm. This code calculates the correction rate of my project. This is all my project. Thank you.